I hope you enjoyed the first half of this conversation. This portion is the live technical interview with our guest. Feel free to follow along and create a solution of your own. So
we'll try with kind of lower level kind of question and see where that takes us. And so obviously the level of the question that you're going to want to ask is going to depend on the experience of the candidate and where they're at, right? So let's start with something simple. Do you know what a palindrome is?
Yes, it's race car, right? It's the same forwards as it is backwards, right?
Correct.
Yes.
So it's a word that you can read either way and it ends up being the same. So your job is to write a function that is going to tell you whether the input is a palindrome or not.
Great.
How would you go about that?
First thing, well, I guess questions. I'm assuming this will be a string that I'm getting.
Yes. Yep.
Okay, great. So just make my notes. Write a function that checks if a string input is a. Ooh, I don't know how to spell pal.
Why? P-A-L-Y.
Why?
I think so. I don't know actually. Like seriously, no, I think it's a Y, right? So I think it's with a Y, but it's fine. Don't worry.
That's fine. VS Code spell checker, we'll get it eventually. Great. So checks if it's a palindrome, it will be a string. So I can think of one solution comes to mind, which would be a basically calling reverse on the function. I don't basically taking the input, calling the dot reverse on the input in JavaScript, which would just flip it backwards, and then comparing the two and seeing if it equals each other. That's a potential solution, but that uses a reverse method, so I don't know if that's
fine. Let's go.
We've got unknown.
I think it's with a Y. N P-A-A-Y P-A-L-Y-N D-R-O-M-E.
Well, I guess that'll be on the spelling section of the technical.
I'll put it in the chat. Now you don't want me spelling your code.
Okay, great. So do you have an example input?
Do you get it in the chat?
Let's see. Oh, there we go.
There you go. Maybe I get it wrong too. All right, whatever. Let's go. But at least we get the spell checker there.
Yes, great. Very helpful VS Code spell check.
See, we both learn.
Yeah.
Yeah.
Great. And I guess we should have an example. So race car was the one that I used. Do you have a different input or a different example that you'd like to use?
No, not particularly. That's up to you. What I'm interested in knowing what examples you want to use.
Yeah, I think we can do race car as one that we know should work, right? And then we can have one that we know should not work. Output. And would you like me to return true, or what would you like to see as a result?
Yes. So that's a very good question, which I think is very important. As you write the prototype of your function, you want to understand the input and the output, right? Just like you say, but in terms of what is the structure of the data you received and what you expect to return. In that case, yes, the function should return a Boolean that tells you whether the string is a palindrome or not.
Great. So given the input race car, our output would be true?
Correct.
Great. And let's go. If we have a second input of coding, the output would be false, correct?
Correct.
Okay, great. So using JavaScript, I'll make our palindrome function, which will take in a input string. And we'll return a return statement. This will be calling our function down here. So we'll have race car, which should be true. Under it, we'll have our false result, which will be coding. Spelling race car wrong here too? No. Okay. So you said one possible solution is to call reverse on it. I believe the right syntax would just be so let's call it reverse string equals input string dot reverse. Let me just check that works, because that syntax should be correct, but.
What do you expect there? Just checking that. Tell me what you expect to see there.
I expect to see race car printed, and then coding to be printed GNIDOC. So basically the reverse of this string.
Okay. And you being in JavaScript, by the way, enables you to do that. But if you had a statically typed language and your function is returning a Boolean, that wouldn't work. So yeah, my 2 cents, you would want to be clear to say, hey, I understand I'm not respecting the contract right now. I'm just testing to see if my reverse is going to work, which makes sense.
Yes. Okay, yep. Great. Oh, reverse just cause an error. I believe.
Is it reverse string? Actually, the entire. I'm not a big JavaScript expert. So, but let me double check.
I think I may need to call split on it first.
Yes, reverse is for arrays. So what are you going to do?
Okay. Well, there's a method I don't. Yeah, I don't think it's gonna come to me. But
I think you're on the right track. When you call split, what does split return? When you call input string.split, what do you get in return?
Each individual letter, right? Spit
character.
out.
You get an array of character.
Yes.
So now you have an array, and you should be able to call the reverse function on it, right?
Yes. Let's see. And reverse. And then I think we can call dot join right away.
Correct.
But
we want to put it back as a string.
Yes. Dot join. I think I'm just.
So when you call reversed string there, what happened on line 18 there? What do you think happens on line 18?
Well, should reverse it and then join it back together in that reversed order.
So that's going to get a bit advanced in terms of programmatic concept, but you're not, so the reverse function is a function that's going to return you the result of reversing reversed string. but it's not going to reverse string in place. In other words, it's not it's up by value, if you want to think about it that way.
Yes. So I called this reverse string, but this is not actually reversed.
Yep.
Instead, I should declare something down here. This is not my best syntax
That's
in
fine.
the world.
Don't worry. That's fine.
But
don't worry about that. So now you assign your result to a variable that you're going to be able to use. What you had on line 18 before just got lost in memory, basically. And your reverse string stayed what it used to be.
Right. So this should just spit out the reverse string now. But coding's not reversed, so I'm curious if reverse is working at all here. It seems like it's not.
It's a bit of a technicality, but the split function expects a parameter in JavaScript. I think that's what you're missing. It's really, so just to take a step back, I don't care about those kind of mistake when we are doing a coding interview. So what if you put empty string as a parameter for split? I think that's what's missing there.
Right, because it's going to take each letter and put it into its own string instead of, it's not just going to...
Correct. You have to tell it what
anything.
to split against. Yeah.
Yes.
That might be it, but of course you want to join as well again, right?
Yes. So this would be it without the join, right? It would be each individual letter. If we add the join.
And you can see that your coding is reversed now. So you just need to join it. And join, it might be the same thing as you empty string, I think.
Yes, sir.
Yeah.
Yeah. Okay.
There you go.
Great. Okay. So then to actually, now we've got it reversed, but to actually solve it, I can write it in conditions saying if actual reverse string is equal to input string. I think on its own that line would be, since it's a Boolean, it would return true, but I can declare that return true. Else return false. We're going to get rid of this return down here. So this should, now that we've declared this, check this string against input string and return true, else return false. Great. So it seems to work for those two.
That's what you expect.
Yes.
So let's go a bit into coding. You said something interesting. What is actual reverse string equal input string? What is that expression?
So equals would be comparing the two. My understanding would be comparing to see that if the two have the same values, but
yeah, I'm sorry, I missed, I didn't ask the question clearly. Let me rephrase the question. The expression, what is the type of the expression actual reverse string equal string when it's evaluated?
The if statement?
To be precise, the expression in the if statement.
Oh, it's checking if the contents of the input string is equal to the now reversed contents of this actual reverse string.
Why don't you try to do a console log actual reverse string equal input string just above your if and see what do you think it's going to write if you do that?
I don't know. Good question. I think it might have some type of error. I just don't know, having the logic in the console.log, what that would. do.
So if you think about this as an expression,
Yeah.
so run it and see what happens.
Sure.
Maybe I'm wrong, again, not very familiar with JavaScript, but yeah, there you go.
Yeah. So it will do that check without even having
what
to do
it does is it looks what's inside the console log, and what's inside the console log is an expression. That expression gets evaluated, and because it's a Boolean expression, it's evaluated to Boolean, and therefore it writes the result as a Boolean, right?
Yeah.
In that case, true or false. In other words, when the console log equals what you return, you can see that, right? When the console log was true, it returns true. When the console log was false, it returned false, right? So you could return actual. What if you do return actual reverse string equal input string equal?
That should work as well, right? Even without the if statement.
Correct.
Yes. I don't need really anything else.
And that's a matter of, I'm pointing that out, but just to try and understand how you think, what is your conceptual understanding of what's going on in memory, how the compiler works, how it works at runtime, those kind of things. But in terms of coding style, and that's going to depend who you work with and how they operate, but that's generally an acceptable syntax. If you take it to the very nitty-gritty detail, you can actually write that entire function in one line.
Right.
I would argue that in your coding style, why do you have reversed, which should be split string, right? If you want to have a correct variable name in that case, or array input or something like that, right? But you take that intermediary step when you split, but you don't take that intermediary step when you reverse and join. So you could arguably split your string, reverse it, and join it within the same call. Maybe. I don't even know if that's actually going to work out. We should try. How about we try?
Yeah.
There is enough chance. Yeah, it should work indeed.
Let's see. Input string dots. I think I may have written the reverse on it, but because I didn't have the split call calling correctly at first, it wouldn't have worked.
Yep. There you go. And then you can delete your first two lines, right? So just thinking about, throughout the interview, thinking about how can you make your code cleaner is important.
Yeah. Let's see. It'd be helpful if I actually call that. Yes, great. So that does work.
There you go. Okay, now we're going to take a step back from the code and try to think about the problem itself.
Yeah.
So a lot of those questions, and tell me if you're not comfortable with what's called big O notation, but a lot of questions, and we can get around it, but a lot of questions in those interviews. One second. Can you hear me?
Yeah.
Hello?
I can hear you. Yeah.
I don't know. I had some music starting in my ear for some reason. So a lot of questions in those interviews revolves around how you think about algorithm and optimizing algorithms, right? And that's where we are going to go next. And a good tool to have a common language with your interviewer there is what's called the big O notation, which is basically a way to express how an algorithm scale in terms of time and in terms of space as you increase the size of the input, for example.
Yeah.
So are you familiar? So one of the questions I would ask is, are you familiar with big O notation?
Yeah, I'm more familiar with big O notation as far as it comes to time complexity than space complexity. You mentioned Cracking the Coding interview. I have what I would say is an intro to that book that I've spent quite a bit of time with big O notation over the last couple of months trying to cement it in my brain.
Yeah, I don't think space complexity, sure, it proves that you can think about it, but nowadays, honestly, even time complexity is a lot more important to understand basically than space. Space, you have infinite amount of space to the click of a button in AWS nowadays. You know what I mean?
Yeah.
I'm exaggerating, and we're talking about memory in that case versus CPU, but something that you're not going to be able to get away is if you have an exponential time complexity, you're not going to be able to do the job that you need to do if your input increases in size, for example. That's just the nature of the beast, even if you have a supercomputer. Quantum computer might actually help solve some of those problems. But so it's great. Let's talk about time complexity. What is the time complexity of that algorithm that you just written?
Yeah, so basically we're taking in an input, and then for each input, we're splitting it, reversing it, we're joining it, and we're returning it. I believe it'd either be O of 1 or O of n. Maybe I just don't know exactly how these may affect it. If any of these would complicate it, but
So
we're taking in.
So let's leave split and genocide, right?
Yeah.
Could be the problem could be that you receive an array of character for what it's worth.
Yeah.
What happens in the function when you call reverse? What happens in there?
So each element in that array is going to be. I don't know exactly how it calls it, but basically it's going to be inserted to the front or the end of the array, right?
Yes. So you will have to read every element in the array in order to write them in the reversed order, right?
Right.
Somewhere or another. We don't really know how it's done, right?
Yeah.
But
So that
can you
makes me
think?
think.
Can you think about another way? So that would be, OFN, and we are in that order of OFN, no matter what we are talking about. But we can be a bit more precise. In that case, you split that OFN as well. You join that OFN as well. Aside from that, within reverse, we are OFN. And the solution that you just mentioned, which is I'm going to read one character at a time, and I'm going to write them in reverse order in another array. Maybe I read from the end of the array to the beginning of the array input, and then I append them into the output array, and then return the output array. That would be going through every one of them. Can you think of a way to not go through every one of them?
Yeah. I think you could solve this problem using a hash where I believe you could solve this problem using a hash where essentially basically have some type of break statement or return false statement if the element is not already in the array or is not already in your hash. But I think you could do that. I don't know if I could necessarily code it out, but that would make sense to me. And it might still be O of n in worst case scenario, but if it was the example coding, right, it might return much faster than O of n on average.
Why so?
Articulating that well? Because if you put G into the array and it looks at maybe the other end of the array, and G is not the last element of the array, right? G would only be the first element of the array. It would only need to look at that first element to go, and then that last element to say this is not a palindrome, right?
Okay. So you're thinking in the context of the palindrome, really.
Yes.
Yeah. Well, that's maybe that's a good way to think about it. So outside of the code, can you write race car, for example, or coding for that matter? And can you think of a way to reverse that string that does not involve going through each and every character?
Yeah. I guess just flipping. I'm really flipping any two characters, right? Yeah. I mean, any two
Okay,
equal
so
characters or opposite characters, right?
Yep. So you're opening the right door there. Let's get a bit deeper. So I think you have the right idea as it relates to try and switching one character with another. How would you go about that? And what would be, if really inside the reverse function there is a loop, how could you make that loop shorter than n, basically? It's still OFN, by the way. We're not changing things dramatically. It's just minutiae optimization.
Yeah. Yeah, I mean,
just conceptually, right? You have coding as a word. How would you go about reversing that string that is not going through every character and writing them in reverse order?
Yeah, I think taking the example of just the first and the last element and comparing those two, if those two are not equal, then we don't need to continue, right? And if those two are, then we can continue.
But now you're in the world of so that's going to be very good. Keep that in memory for the next question. Because that's a very important clue for the next question. For now, we're just trying to reverse the string, whether it's a palindrome or not. We want to reverse it, and you say flipping character. So for example, for coding, your first step would flip the C and the G, right?
Yep.
What would you do next?
Flip the O and the N.
Okay. Can we write, so instead of line 20, if you can comment out line 20, do you think we can write a quick loop that actually does what you're talking about here? And what would that loop look like? Of course, you would have to split it into an array, right?
Yeah. It would look, we could do some type of for equals 0, right? Like some type of for in loop where I is less than put string dot length I plus equal 1, type of for loop like that where we're going to
I think your increment is 1 plus equal 1. You want it to be I plus equal 1, I think.
That one catches me once in a while.
That's fine. Don't worry.
Yeah, I'm trying to think of how to do this without having nested loops, because in my mind, having two different pointers, right, that kind of meet at the middle makes sense. But that's going to be greater than O of n, right? So that's not a better solution.
If you nest another loop, that's going to, yes, you're right. That's going to change that. Why would you need, though?
I was thinking of having...
So on the... So you've got those two pointers, right, that are going from the extreme ends of the string and that are going to kind of meet in the middle. Is that what you're thinking about?
Yes, yeah.
So if you know the position of one, implicitly you know the position of the other one, right? Because if I move that one that way, I have to move that one that way.
Yeah, I was thinking of making the second pointer the second loop. But I don't necessarily need to have a second loop to have a second pointer, right? I could have...
Correct. If you don't want to write the exact code, what I'm interested in is in the value of those pointers. So you can put some pseudocode in there and you can say interchange character with character. And what I'm interested in is the index that you put in there.
Yeah. So I would think of the loop.
Or you can write code if you prefer, of course. Huh?
Yeah. Of input string, basically I, and then needs to be the equivalent of, which like this at this point is equivalent to 0, right? Which would be the first element in here. Checking I'm just trying to think of how to make the second. I could probably do something like this. Input string dot length minus 1, right? And then doing string j, and then I plus equals 1, j equals 1, if that makes sense. Basically having this j equal the last element.
I think I follow your idea. However, there is a couple of problems. First, your I plus equal 1 is already part of your loop execution.
Right.
So you can, so because that would be I plus equal 2 at the end.
Yeah.
The second thing is your j is initialized there.
Yeah.
So that's an initialization, but you put it inside your loop. So every time you get in the loop, your j is going to reinitialize to that value. You see what I mean?
Yeah.
So you would either want to put it outside of your loop, or you can also, you would want to put it outside of your loop, right?
Yeah. That makes sense. Right. Because we have access to input string already, so we can assign that outside of it. We can increment I within the loop. We can decrement j. So yeah, I mean, I would write the rest of that as something like, really don't have to write, I guess, anything there.
Correct. So really what you want to check, if they are not equal, then you want to return false. You don't do anything if they're equal. You just go to the next iteration.
This more effectively like this, right? And then otherwise at the end just return true, right? So it'll return true if it makes it all the way through, right?
All right, let's try it. You think you're ready to try it there, or
I think we might run into an issue because at some point j is going, well, j might go too far down, or if there's an uneven number of characters in the string, might be an issue too, right? If we have a as a central point, I'm not entirely sure how that will handle it.
You don't care about the central character, do you, for a palindrome? The central,
I guess they would be the same, right?
Yeah, you don't care about the central one.
Yeah. Okay. Let's see. There may be.
And they would be the same. You're right. In that case, I and j would be the same.
Yeah.
So does it work? Seems to, right?
Seems to.
All right. So the reason, if you remember the question, just so you know, the question was write the code to reverse the string. So what we are trying to do is change to have our own implementation of reverse. What you did is you take it one step further, say my function is a palindrome detection. I just want to compare.
Right.
And so there is something you're not seeing there. We're going to try and keep it, in time, that if you had implemented the same algorithm and instead of checking whether the character are equal, you're just flipping them, you would have ended up with a reversed string that would be equal to your input string. And the reason why is because you're going through the entire array. And really, you want to stop in the middle. And the whole point of what we're trying to do here is optimizing. So we knew already a way to reverse the string by going through all characters. Now you find a way to reverse the string. You really are reading all the characters, but in terms of loop iteration, you're at n/2 because you want to stop in the middle. Once you've checked that the first is equal to the last, you don't want to check that the last is equal to the first the second time when I and j are introverted.
Yeah.
So when I and j come together, then that you would want to stop. So if you go back to your code, basically there are multiple ways to do that. One way would just be to iterate I until input string that length divided by 2, and that's going to be rounded. That's going to be rounded lower. So it doesn't matter, because if there is an odd number, you don't care about the central character. So that would work. Let's try, make sure. Maybe I'm wrong. Who knows? But that should still work.
Yeah.
You see?
Right.
Another way is to, in your loop, you say if j is smaller than I, then I know I'm done, you know, those kind of things. But really now you're optimizing, right? Because you get the same result by half the iteration in that case. Right?
Yeah. Yeah.
All right. So maybe we go into a last question, Taylor. You said something that was very interesting, which actually you ended up implementing, which is I want to compare the first and the last one first, right? Mm-hmm. So if you compare, let me try not to get you too much. Can you think of a, well, I don't know how, let me think about it for a second. If you figured out that the first and the last one are the same, what kind of a problem do you end up with at that point? Like if you look at race car and you know that the first and the last one are the same, what is the new problem that you have to solve?
To see if the second one and the second to last one are the same?
That's very much an iterative way of thinking. And that's what you implemented, an iteration that actually does that. Mm-hmm. Can you think of another way to think about solving that particular problem from a purely algorithmic standpoint? So in other words, now you have the same problem once you figured out that R and R as the same. Now you want to check if ASCA is a palindrome, right?
Yeah.
What kind of algorithmic technique would you use to do that?
You're saying without comparing the rest of them?
I'm just taking a step back and making the observation that once that I have compared that the two extremes of the string are the same, then I'm left with a smaller problem, which is looking at the remaining string without the first and the last one and checking whether it's a palindrome or not. So I can do that same thing again.
Oh, interesting. Interesting. So I think what I'm is like if those two are the same, we want to check. I guess we could write in something similar to this equals statement right here on line 33, basically running that to see if that subsect is the same. Basically, if we know the first one is, let's check, because if the rest of them are equal, then great, we don't have to run any more inputs. But if the first one isn't, then we can just run false, right?
Correct. Yep. Which is what you do in your iteration loop, right? As soon as you see that two that are symmetrical with equal to the middle are not the same, you just say goodbye. I don't need to check anymore, right? So and that again, I'm learning too through this, Taylor, and it's very much academic. It's very much, again, I understand, just to put it out there, right? I understand that this is a very narrow, as I said in the first part of the interview, way to look at things, but it just helps gauge certain side of things. And so in algorithmic, for those who have done probably more, let's say, academic learning of those things, that's something that you will learn no matter what in the coding interview, cracking the coding interview, which which has all the basic of algorithmic that you need to understand. But there's something called recursivity, which is calling a function calling itself. And so the function is palindrome could simply check whether the first and last one are the same. And if they are, then it calls itself on the substring excluding those two extreme characters.
Sure.
Until it's down to a string that is either 0 or 1 character. If it's a string that's 0 or 1 character, you can return true. And so you have a stack call of all those functions where at the beginning it checks race car, then it checks ace car, then it checks whatever is the substring until it gets to the E, and then it returns true throughout the entire tree, and your base function then returns true. So it's very basic algorithmic, and then yeah, we can talk about time complexity. It's just another approach. It's interesting for me personally. It has always been very challenging to think about things that way. Just so you know, I'm very much iterative kind of thinker and try to think about all sorts of ways the way we did it. It happens that particular problem of finding whether a word is a palindrome or not is applicable in both worlds very well. But some particular problem are very suited, like going through a tree is, and there are many declination of that particular problem solving. That, in essence, is a problem that's very hard to do by iteration and very easy to solve recursively, at least in terms of the amount of code that you would have to write, right?
Yeah.
So
you've caught me right in the middle of.
It's just another way to think about it.
Yeah, I've just been getting into recursion. And it's funny that once you said recursion, I was like, oh, the thing that's been, I don't know if it's difficult, but just a new way of thinking about it is basically the way I think about recursion is like pretend like that problem's already solved, right? And then just jump to the next step, right? Because that's what you're actually usually running the recursion on, and then the base case is what can break you out. I wish I had my other repo up, but it's all the last 2 weeks. Those have been my practice problems. Have been going through recursion, so they're all a lot of these same problems that I've been trying to solve recursively for the first time. So yeah, it's a concept.
Do you want to give it a shot? Yep, go ahead. Sorry.
I just think it's a concept that a lot of people, especially if you come out of a boot camp, that you don't necessarily
hear about,
learn, right, or think through all that often.
Yeah, and the truth is that, so again, that's my approach, and I like to go into those kind of things early on to try and see certain things. There are other exercises that don't necessarily involve that, but you need to know your basic for those kind of interview. We're talking about hash table. That's not really applicable in the present case because the position is as important as the content in that case. But yeah, all those things, there is probably 6 or 7 different ways to think about algorithm that you need to really be familiar with in order to perform very well on those interviews. But you did quite okay, for how long have you been coding for?
About 6 months, maybe August or September was when I started picking it up.
That's, give yourself a pat in the back. That's stuff that you learn in a CS curriculum on the, I don't know, second, third year of CS classes, and it's all, it's different. And so I completely understand that you really learn the useful skill that you're going to be applying on a day-to-day basis. Now, the tricky thing is that, especially if you interview in a FANG company, that is going to be a big part of it. And you need to be very familiar with it and have it very, very nailed down. If you want, we can give it a try now that you have a good grasp on the concept.
Yeah,
yes.
So let me, it's definitely been something that I've been working through and wrapping my head around it. But like I said, I try to think of like,
so I'll help you along the way. Yeah.
Yeah. So if we've already solved the problem, right? If our, let's just assume we've solved the problem that checking the first two letters, right? So then it moved to how do we check the ones inside that? Because it's typically where the recursion call actually comes in. So I can make our base case should be if input string. And I'm trying to think of how I've been writing them. I feel like it's more syntax than anything that I'm trying to think through. Basically, if that the way I've been writing them, often my recursive solutions is basically splicing or slicing from the end. So then, like when input string dot length equals 0 or something like that. Let's see.
So in that particular case, what would happen if you have a not number of letters?
Ooh.
When you get to the end, when you get to the middle and it's a palindrome. I shouldn't ask a question. Go ahead. You're on the right track.
No. That's a good question. I mean, I could do string dot, because if it equals 0 or 1, right?
Yes.
I'm trying to remember what. I think I just want to return 0. The actual recursion part, I was thinking of, and then like what we're actually going to return at the end, right? I think would be input string 0 or something similar, and then in the middle is what I'd actually need to write for the recursion. The other thing going in my head is I know we could definitely use, this is what I've been learning recently about recursion, is what is it? Memorization to make this more efficient, right? To cut it in half, but I'm not comfortable
so I don't
with that
think
yet, so.
in that particular case, you don't have to do caching. Well, it wouldn't help you to do caching because you're not resolving a subset of problems over and over again. When you're in trees, that concept is very important. In that particular case, you're just, the complexity is still often, time complexity as well as space complexity in that case are still often. So it's not like you're going to optimize that by using a caching mechanism like memoization, I think is the name of it.
Yeah.
I don't remember the technical term, but
Yeah.
so you can leave that aside. And it's a much more simple recursive problem if you want to think about it that way, from that perspective. The reason why is because you're gonna, inside the function, you're gonna call the function just one. So it's gonna be a straight line of call in your stack, basically. It's not gonna branch like a tree if you were to call it 2 or more times inside the function.
Yeah. Yeah, this is a part where it's you need to check if this equals yeah, I don't know. I think I'm in over my head here.
So let's take a step back.
Yeah.
It's cool. It's great that you're over your head and outside your comfort zone. You know, we talk about growth mindset. That's exactly where you want to be. I'm trying not to give the answers
Yeah.
because I know that if I don't and you really try hard, then it's going to retain a lot better. So that's beyond the interview. It's just maybe having fun
Yeah.
together. And I hope you see it that way because that's gonna retain a lot more. So there is two parts always to your recursion. One is your end condition, which you have figured out on line 35, which is you know that when you add an empty string or a string of one character, you're done and it is a palindrome. Okay? So when it's a palindrome, what should your function return? Yes, exactly. That's the first thing. The second thing is when it's not a palindrome, or when it's not an empty string or one character string, what is the next thing you want to do? Without looking at the code, just think about the string in your head. You're in the middle. There is I don't know, 5 character string that you've received. In that particular step of the recursion, what are you doing?
I'm just comparing or basically calling recursion input string, or calling recursion palindrome.
Not always. You would want to call recursion palindrome only in a specific case. You were going to say, I want to check if. What do you want to check if? That's a good way to start. There is always an if hidden in there.
Yeah, basically if input string 0, right, whichever would be the first element, is equal to the last element, right?
Yes.
Input string length minus 1, or
and let's not write code yet. Let's not write code yet. Let's think about the problem, okay? So you want to check the first and the last character. If they are the same, what do you want to do?
If those are the same, then I want to run. Well, then I just want to move on to the next characters, right? Basically remove those characters.
You're back into your iterative mindset. You're back into the loop. Don't think about the loop. You've checked the first and the last are the same. What do you want to do from a recursion standpoint?
So then I'm actually calling my recursion?
Yes, you've reduced the problem because now you can exclude the first and last one.
Yes.
And just reapply that same algorithm to the substring that exclude the first and last one, right?
Yes, right.
What do you want to do if they are not the same?
Return false.
Correct.
Yeah.
So I think you've got all the elements in hands now to write your code. So first you want to check the first and last one. If they are not the same, you want to return false. And if they are the same, let's see what you do. There is a one last trick that you didn't pick on, but maybe you have it, you just didn't say it.
Do you think if that's valid syntax, if that'll run? And if that is true, then we want to run return recursion. I might need a... Okay, so this might be incorrect syntax. I might need to go input string.
So
length
Yep. Yep.
minus 1.
Yes, correct.
So I'm actually
This is
calling the
where
character.
I'm just going to make a little parenthesis, but this is where a statically typed language actually makes your life a lot easier, because the compiler would have, even the interpreter would have told you you're comparing a character to an integer, because you were comparing the content of the string as a specified index with an index.
Mm-hmm.
So there was, but JavaScript doesn't care, because it's loosely typed. Of course, you can write code faster, but it's easier to make mistakes. So you have to be more vigilant. That's why you have things like TypeScript on the top of it and the things. But yeah, anyway, it's an interesting. But yes, it's very important when you write a condition like that. You want to make sure that the thing you're comparing are of the same nature. And you caught on it. I didn't call it, and you caught on it. So good for you. What about the return? So I think that was the thing you were missing when you explain it. You say, I'm going to call the function. Actually, what you want to do is return the result of calling the function, which is what you've put in there. Now, there is something missing. I don't know what splice does actually. Does it, if you do that, is that going to remove the first and last character? I would use substring, just to be clear. Can we use substring?
I believe splice will remove the last one.
Okay, so that's not what you want, right? You want to exclude the first and last one, right?
Yes.
What about substring? What if we use substring here? There.
Oh, I don't know if I know substring. Is that?
Google it. Google what is string.substring in a... Substring is basically a function to which you pass two parameters, the start index and the end index, and he's going to get the substring from your original string.
Oh, interesting. So like 0 and then reindex string dot length minus 1.
Well, that would be your entire string, wouldn't it? Right? So you want to exclude the first one and exclude the last one. Yeah.
Okay.
Yep.
So we're calling it. Oh, that's helpful. I'm glad I know about substring now.
Yep. Yeah, that's going to be, I mean, no matter what you do, we are deep into algorithm and stuff like that. That substring is going to be something that you use over and over and over again. That's very basic, important part of your tool set. Yeah.
Yeah, I've used slice and splice, which basically
in
will
any
remove
language
the element, but interesting. Okay, so this...
Yeah, I'm not too familiar with JavaScript syntax. Yeah, with Node in that case.
Seems like it should work because we're calling it, passing an input string with those two elements taken off of it. So then it will just be on the next, and then it should work its way down, right?
I think it should. Let's see. I might be wrong.
Let's see. Oh no, substring.
Well, the problem is your function name to start with. Oh, there is something else. Yeah. Mm-hmm.
We're gonna. It doesn't like substring, but I don't know why.
So that might be my mistake. Let me Google it really quick for you.
Let me see if
you have it right. It's just there is no uppercase. So it's substring with the second S. You put an uppercase. It's just substring like that. Yeah, that's it.
Okay, we've got false, false. If 0 is equal to...
All right, so we are into debugging land now.
Yes. Else return false. I don't know if I need that else statement, because I want it to run.
Yep, either way.
Yeah, I think, no, Okay.
Either it's the same thing, what you wrote,
Yeah.
essentially. You can leave it like that. That's fine too. There is another problem though.
Interesting. I think our base case input string dot length or 1, it's going to return true. If string 0 is equal to -1, I don't know if I see it. Palindrome, we're calling it with input string as we are here, but with the substring 1. Is that syntax correct with the comma?
Yes.
Yes. Yeah, I don't know.
So what would you do if you were left to yourself there?
If I was left to myself,
Yes.
I'd probably look up the syntax for splice because that's how I've
Look
solved
the
it in the
syntax.
past.
Do it. Do
Yeah.
it.
Let me see.
Yep.
Let me see.
But that's yep.
This might not be my my actual issue though.
It's more how you think about it. That's perfectly fair to try and see another way to do it.
Yeah, I'm trying to basically how I done it in the past, I think was using input string dot slice 1 plus, and we need to call input string 0. Because this will basically, we're calling input string, and this will take off the last element, and then we'll call it with 0. Is how I was doing my recursion calls before, but that's still going to be false.
But what are you? Yeah, I'm not quite sure what you're doing there now. I liked it more with your substring, because you're adding the first character at the end of the string, basically, is what you're doing at the end of the sliced string is what you're doing there. Actually, you want to exclude the first character and the last one. How about you write some debug code, some console log, so that you can see how the iteration go and see if that makes sense or not.
Yeah. Well, I want to see, let me get back to how we had it written before, because I want to see what that's spitting out.
So, yeah, exactly. And that's a good technique for you to have, right? It's always in there. You can console log whatever to better understand what's going on and why it's returning false and not true.
Yeah.
For race car, right?
Oh, well.
Would you want, because, okay, so now you yes, what you would want is what you pass as a parameter. Exactly.
Yes.
You probably have one more parenthesis. There you go.
ACEC.
So I see. Stupid me, because I didn't see it either. Now I see it. Can you see it?
It's that
we both learned something today. Again,
we can't do -2, right?
So substring in JavaScript basically takes two parameters. I was assuming that it was the index of the first and the index of the last, and I should know better because that's not the right way to do it. What it takes as parameter is index of the first parameter and then the number of characters that you want from that. So in that case, it would be 1 and -1. It's a length. The second one is a length. It's probably right there under our nose in the autocomplete, by the way. No. So it would be the length -1, right? So if you have 5 characters, that's going to be, well, it should be -2 as well, right?
You would think.
So now it works, but I'm kind of lost actually.
Oh, but it's only taking off one every time from the front.
At the senior engineer not knowing substring in JavaScript.
If it was 2 and 2, though, it would work, right? Yeah. So 2 and 2 or 1 and 1, they would just need to be the same.
Which is what we had originally. We didn't have it that way originally. That's what I would want to see, right?
Yes. We had
something else I didn't realize. Sorry.
No, that's
yes.
Yeah, we had 2. Yep. We wanted 1.
So it's -1 because I thought it was a length and it's actually an index. Is that right? Let me double check really quick. Yes. So I thought it was a start character and a length, and it's actually a start character and an end character. And so in that case, if it was a length parameter, so you start from the second one, which because we are 0 index is 1, and the length, it would be -2 because you want to exclude the first one and the last one.
Right.
If it's not a length parameter and it's actually an index parameter, then you want to be length -1.
Yeah. Okay.
Right?
That makes sense.
But yeah,
no.
You got it. I mean, it's technical. It's at the end of the day, we stuttered on technicalities of how substring work in JavaScript, which I certainly am not an expert at. Sorry about that. But you got the gist of how to implement the recursive algorithm, which is basically, if I exclude the first and last character of the string, I end up with the same problem with a smaller string. So that should immediately say, okay, recursion. When you implement your recursion, you go about it the right way, which is first you implement your exit return strategy in that case, which is if I end up with an empty string or a string of 1 character, I know it's a palindrome. At that point, I can return true, and it's going to return true across the call stack. If I'm not with a string of 1 or 0 character, then I need to compare the first one and last one, and if they are the same, then I can go to the next level of recursion by returning the value of the function on the substring. Or if that's not the case, I can return false, which whether you put it in the else or outside of the if is going to be the same thing in that case.
Yeah.
But it's all those steps basically. There's no, then you can get a lot more in depth with recursion algorithm with things like memorization that you remind me of that word that I haven't heard in Ian's. But yeah, that's caching strategy when you do true recursion and those kind of things. But that becomes a bit more complex. I think as you grow as a developer, you're going to do more and more of it, and you're going to get to understand it more and more. It's fun.
Yeah. Well, thank you. I mean, this has been great. I really appreciate it. And I feel like 1, I learned about subscreen, but 2, that's the first time. Well, I've been learning recursion. It's the first time I've ever had to, try to pull it out of my head in an actual, when someone asked me about it. So that's great.
Yeah. On that last stuttering, first, I'm a bit ashamed not to know how substring work in JavaScript. I used it but long ago. To each his own. It proves also that I don't know. As you get older, I guess you gain in experience, and on the people side of things is mostly what I do nowadays. And you lose in sharpness. My memory, my sharpness is certainly not where it used to be. So it's humbling. We also learned that when it doesn't work as you expect it to work, the best thing to do is just write some debugging log in your code and try to understand what's going on and adjust your code accordingly, which is exactly where you ended up going, and that's great. Yeah. And that's also something that you want to show in the interview that you are going to do. It's probably a better approach than saying I'm going to Google it. Is I'm going to put some debugging in my code to try and understand what's going on.
Yeah. And I think that can be difficult sometimes in an interview setting, being like, I'm going to write a console statement here, but that's usually what people want to see, right? Versus just silence while someone thinks, right? That's, I always used to
Which is
say,
okay. Yeah.
people aren't mind readers, right? So if you're in an interview setting and you're not like, if you
Yes.
do need to take a silence,
Yes.
it's better to say, hey, I just need to think through this for a second, but otherwise try to talk out loud, because at least they know where you're going, right? Otherwise, it can be difficult, right, to tell as an interviewer.
And you're going to have different interview where you're going to have interviewers that chime in because they themselves feeling comfortable with the silence. You're going to have others. Like I'm a big proponent of in one-on-ones as well, big proponent of silence, and because you need to give the space to the person.
Yeah.
So when I do that, maybe I should be more clear. See, that's something else I learned. If I'm going to tell you at the beginning of the interview, if there is a silence, don't worry. It's just that I'm letting you time in order to get through it, for example. Yeah. So
Great.
yeah.
Well,
Great job,
I
though.
appreciate it.
You're hired.
Anything you want to, I mean, this has been great. I really enjoyed the conversation. Anything you want to plug? Lively, you guys hiring? Anything you want to share with the world before we go?
No, just enjoy the journey, have fun. Those interviews can be daunting and can be scary. At the end of the day, keep in mind that nobody's perfect, that try to have fun, try to stay curious, try to be clear about who you are, try to have them be clear about who they are as well, and take it from there,
Great. I love it. Well, I appreciate it, Francois.
Thank you very much, Taylor.
Thank you so much for listening. If you enjoyed the show, please subscribe on YouTube or your favorite podcasting app at The Professional Technical Interviewee. I want to thank my guest and my wonderful editor and producer, Dustin Bays. If you're interested in sharing your technical interview advice and being on the show, please reach out at dorsetttaylordev@gmail.com. Until next time, keep practicing.